Indole is an important aromatic heterocyclic compound. It is basically belong to benzopyrrole family. It consists of benzene ring and pyrrole. It is a very important precursor for amino acids such as tryptophan and neurotransmitter serotonin. So its biological importance is very significant. As far as its synthesis is concerned, indole was first synthesized by Emil Fischer, who was a carbohydrate chemist and got 1902 Nobel Prize for his discovery of phenylhydrazine. This synthesis was one of the most important and significant discovery in organic chemistry and serve as the oldest and most reliable method for synthesis of substituted indole derivatives. The reaction for indole synthesis is simple. Here we can see that phenylhydrazine react with aldehyde or ketone in the presence of acidic medium for give rise to formation of an indole or substituted indole derivative. The reaction usually proceeds through intermediate formation of imine. So imine form for transformation of the reactant into product. Now we will check out the mechanism how these two reactants such as phenylhydrazine and a carbonyl compound such as aldehyde or ketone react for giving rise to formation of an indole. So let us focus on mechanism of the reaction. We have phenylhydrazine which react with cyclohexanone. It is important to note that when amine react with carbonyl compounds such as aldehyde and ketone, a condensation reaction takes place. The amino group acts as a nucleophilic agent and it to electrophilic carbon of the carbonyl carbon. So it gives rise to formation of an imine functionality. Here the attack amino nitrogen attack because it has lone pair of electron. It attack a carbonyl carbon. In this fashion, it gives rise to formation of an intermediate complex. Nitrogen will require positive charge and it will link to a proton shift will take place. As we have used acetic acid as a reaction medium, which will protonate the hydroxyl group. In the next step, water molecule will release or giving structure like this. Nitrogen will require positive charge, and ultimately it will deprotonate for giving an ultimate structure. Like this, which is known as amine. So if amine now undergoes a sort of tautomerism, in order to clarify the structure, let me write it a bit more clear again. This is linked. We have two hydrogen here because it's methylene group. The double bond will attack the proton. This will shift into this direction, and ultimately we will obtain a product or intermediate structure like this one. Now this structure will undergo sigmatropic rearrangement in a fashion like here a new bond will form. The double bond will transform to this position, and here this bond will cleave. So what will be the resultant structure? Aromaticity will be lost in this step. Because a new bond is formed. This is carbon nitrogen double bond. And here we have double bond nitrogen. So in the next step, again proton will attack. Here we have hydrogen which will shift to this position in order to restore the aromaticity or getting the structure like this. Here the amino group will be restored, and rest of the molecule will remain same. Now again this nitrogen will attack this carbon atom. Let me clarify it. The result, negative charge will occupy a nitrogen atom, which will ultimately attack a proton, or it will abstract a proton. This will give us a structure like this. Here we will get an NH2 group. Here we have lone pair of electron. The amino group will be protonated. Here nitrogen will have positive charge, and next this hydrogen will be abstracted by a base part of the acid or Fe, and it will transform like this, and we will get the ultimate derivative of indole. So this is all about Fischer-Indole synthesis. I hope you got a clear understanding of what exactly happened in the reaction.